Okay, so finally, the last question for this paper, question number 9. This is a probability question. So this is topic 4. So this question is from topic 4, probability section. So let's read the question together. So we have a bag contains buttons which are either red or blue. Initially, the bag contains 3 red buttons and 1 blue buttons. So 3 red and 1 blue. Okay, then we have these descriptions. So 1 button from the back, and she then replaces the button and adds 1 extra button of the same color. And for example, if she selects a red button, she then replaces it 1 extra red button, so that the back then contains 4 red buttons and 1 blue button. And Francine then randomly selects a second button from the back. And we have a tree diagram here. So now we need to find the value of the P and value of the Q. Okay, then we do know that once we chose 1 button, we are adding an extra 1. So the number of the total button in that bag has changed it to 5. So both P and Q gets the 5 as denominator, total button, number of the button. However, to choose the red button from these selections, since we have chosen the blue button from the beginning, the number of the red button hasn't changed, so it is these three choices only for the red button. However, for the blue button, we have chosen blue at the beginning, and we replaced it, and then we added another blue button into that box. So now the total number of the blue button for this case is 2. So we do know that the value of the P is equal to 3 over 5, and the value of the Q is equal to 2 over 5. Question B, we need to show that the probability that Francis selects 2 buttons of the same color is 7 over 10. So since we have to show that, let's do this question here. So question B, since we need to show that the probability that Francis selects 2 buttons of the same color is 7 over 10, we have to say probability of the same color is same as probability that choosing red and red plus probability of choosing blue and blue. Okay, then now we know that probabilities are red red or blue blue, so we're going to use 3 over 4 and 4 over 5 and 1 over 4 and 2 over 5. So we do 3 over 4 times 4 over 5 plus 1 over 4 times 2 over 5. Then we can simplify these values. Then we get 3 over 5 plus 1 over 10, which is same as 6 over 10 plus 1 over 10, so 7 over 10. So we have shown that the probability that Francis selects 2 buttons of the same color is 7 over 10. So it's QED. Then question C, we need to find the probability that she selects 2 buttons given that the Francis selects 2 buttons of the same color. So we have to do conditional probability. So question C, we can say the probability that the Francis selects the 2 red buttons, so red, red, given that the 2 buttons of the same color, so same color. Then we can do 3 over 4 times 4 over 5 over 7 over 10. Okay, then we get 3 over 5 over 7 over 10, which is same as 30 over 35. Since we got our final answer as 30 over 35, this can be simplified, right? So it means we have 6 over 7 as final answer. Okay, then let's try the question D. We need to find the value of the A and the value of the B, right? So the variable x is defined as the number of the red buttons selected by the Francis. So question A, it means that the value when Francis chose one red button. Uh, the value of the B means the value when the Francis chose the two red buttons. So it means we can find the, let's do question D here. Okay, then for the A value, right, we have to choose the cases where we only choose one red buttons. So for the A, case of the A, we can say that probability of one red, okay, means for the first case where we start with the red by choosing red button 3/4, that means when we choose the second button we have to choose blue button, right? And means when we choose the blue as our first button, then we have to choose red as our second button. So we choose red button as our first button, so 3/4, and then we have to choose blue next, so 1/5. And we have another case where we choose the blue first and choose red next, right? Then when you simplify these values, can you simplify this further? Not really, right? Then we end up with the 3/20 plus 3/20. So we end up with the 6/20 or 3/10 as our A value. Okay, so A value is 3/10. Then the B value is case where we chose two red buttons. So two red. So that means using the tree diagram again, we can say first button we choose red, second button we choose red. Okay, and there's only one case where we can do this, right? So we can say the probability where we choose two red buttons is same as 3/4 times 4/5, and this is same as 12/20 or 6/10. So B value is 6/10. So we can say A is 3/10 and B value is 6/10. Okay, or we can simplify this further as a 3/5. Okay, then question E, we need to find the expected number of the red buttons selected by the Francis. You can find the formula for the expected value from your formula booklet, right? You can find it here, right? Expected value. So to find the expected value, what we need to do is we have to multiply the variable x value with each probability and do the same thing for the every single variable and then add them all together. So we're going to do expected value is same as 0 times 1/10, right? 0 times 1/10 plus 1 times 3/10 and 2 times 6/10. Then we get 0 here and then 3/10 plus 12/10, which is same as 15/10. So the answer, the final answer is 3/2. Okay, so this is the expected value for this case. So we have new information. So Francis restarts the process with the 3 red buttons and 1 blue button in the bag. She selects the buttons as before, replacing the button and adding 1 extra button of the same color each time until she selects a blue button. Question F. Given that the first 2 buttons she selects are red, write down the probability that the next button she selects is the blue. So what you can do is we can just continue with the tree diagram, right? So if we choose red as our first button, right? Because we have to choose 2 buttons, the first 2 buttons as red. That means we have 3/4 as a probability of choosing red button. And next, if we choose red buttons again, since we are replacing the one that we picked and adding another one, the next probability will be 4 over 5. And again, lastly, we are choosing blue. So means at this point, we now have total 6 buttons in that bag because we have replaced the second red button and added another one, but still there's only one blue button, right? So 1 over 6. So we can say that question F, the probability of choosing one blue given that two red are chosen is same as is 1 over 6. Okay. Okay, then let's do final question. Okay, so the probability that she selects the first blue button after n selections in total is 3 over 56. We need to find the value of the n, right? So let's consider uh, the x. Let's do question G here. So let's consider the big X, capital X, as the number of the selections. Okay, so when you say x equals number of the selection, right? So means how many we select the button to get the one blue button. That's what that means. So it means simply it means if we select the one time, and if we select the button twice, and then if we select the blue button in the second time, let's say we select the blue button the third time when you select the button 3 times, and when you pick up the button 4 times, and if our first blue button shows up in the fourth time, and then also there can be cases where we select the button 5 times and then the button shows up as a fifth one. Okay, so if we select the button only one time, and then if a blue button shows up as a first button, then our probability is 1 over 4, right? And if we select the button twice, and then if our button shows up as a second, then we know that picking up the red button for the first time is 3 over 4, and pick up the blue button as a second button is 1 over 5, right? Because we gained the extra button. And same thing if we select the button 3 times, and if blue button shows up as the third button, then our probability is like 3 over 4 times 4 over 5 times 1 over 6. Okay, then if they simplify these values, they are equal to 1 over 10. So it's still not 3 over 56, right? Then let's try the cases where we pick up the 4 buttons, and then our last button, the fourth button, is the blue. Then we have a like this, 4 over 5 and 5 over 6 and 1 over 7. And when you do this, we end up with, let's say, 1 over 14. Okay, then if we select the 5 buttons and choose the blue button as the last one, we get 3 over 4 times 4 over 5 times 5 over 6 times 6 over 7 times 1 over 8. Okay, and when you do this, we end up with the values 6 gets simplified, 4 and 4, 5 all gets simplified, and we end up with the 3 over 56, right? So we know that when you select 5 buttons, and if we choose the first blue button at the 5th times, then we get the probability equals to 3 over 56. So the value is value of n is equal to 5.